Καλησπέρα σε όλους και αμέσως κάνω το switch στα αγγλικά. So, hello everyone. Today's talk is about the open source technologies within the concept of self-healing systems. And just to clarify something, when we talk about self-healing, we don't talk about meditation. Okay? It's just the ability of systems to heal themselves from threats, from cyber threats. So, what we're going to see? We're going to see advantages of utilizing self-healing mechanisms in open source software, how self-healing improves the efficiency of open source software, open source self-healing, and self-healing within the framework of CS-aware, which is going to explain later what is CS-aware. For now, just to mention, CS-aware is a research project, and we're going to talk about its objectives later. Okay, so as we said, self-healing is about healing. It's about systems healing themselves from threats, mitigation, as we say it, as we call it. But why we need it? Why don't we just, go and mitigate the threat ourselves? We have intrusion detection systems. We have antivirus software. Okay, the main reason why we need self-healing is what we call the complexity problem, the complexity of modern softwares. So there are a lot of challenges concerning the efficiency and reliability of systems because the workload is too much and just human administration is not able to cope with these challenges. So, and there comes problems such as system management cost, maintainability cost, it increases, and also system complexity affects system reliability and availability. Especially availability is really important because when the system is not available, it's a disaster. So, what does self-healing? Self-healing addresses the rising complexity of systems. It comes as a solution. It's an external solution. It's external to the system. It's not integrated, although some implementations of self-healing are integrated, and they have some advantages. We're going to analyze it later. And system reliability is enhanced, and maintenance cost is, of course, reduced because we don't have to deal with all this workload, with all this complexity. The system is able to mitigate themselves, and the best is the prevention, when it comes to prevention. When self-healing is intelligent, it also can prevent threats. So, let's understand better what is self-healing. Self-healing, the concept of self-healing includes classification and analysis of sensory data, autonomous detection of possible threats, and autonomous mitigation of threats. So, what we do? We classify and analyze sensory data. We detect possible threats, but we are not just an antivirus system. We don't stop there. We go further and we mitigate these threats. That's what makes self-healing special. Okay, there are a lot of models out there for self-healing. And of course, there are various criteria which separate these models. We have the management style, which is separated to top-down and bottom-up, application environments, embedded systems, OS and others, and the learning methodology, which is unsupervised, semi-supervised, and fully supervised. So, about management techniques. We have the top-down, as we said, which has authoritative nodes which facilitate and observe the operation of child nodes. That's why it's called top-down. We have authoritative nodes, and they have their child nodes which have a lower priority, and the authoritative nodes do all this management stuff. Some models of the top-down implementations are Rainbow, Marks+, SASE, and Moses. There are a lot of other models as well, but these are the important ones. And we have the bottom-up management models. They utilize ad hoc strategy. The components are able to communicate between themselves and assign work to each other in order to ensure the reliability of services in case some source is out of service. And of course, here we have four more important models, which is the embryo-aware, the VCure, the GPAC, and the UBL model. Here comes the evaluation of these models. Why are they good? Why are they used? Why we should implement these models? Oh, okay, regarding Rainbow, it facilitates the management of self-healing. It provides a controllable environment as well. Also, SSR minimizes the need of human intervention. The response time is reduced. It's really important. And here we can add the cybersecurity awareness. And we have the autonomous maintainability. Marks+. Self-healing managers offer a degree of autonomy in managing systems. Marks+ utilizes self-healing managers, so human administration doesn't have that much workload, and we are able to cope with the challenges of the system complexity. Behavioral unit tests and service availability mapping lessens the fault detection time, and Marks+ also isolates the faulty service from the rest of services, which is good because in that way, if we have a faulty service, it's isolated and it does not affect any other services, so we have a chain of faults. Okay, VCure nodes have the ability to assign tasks to each other because it's a bottom-up, so it utilizes ad hoc strategy. Possible to use on remote systems, which is really important. GPAC controlled environment with regards to the implementation of self-healing and easier reconfiguration of self-healing mechanisms. It's good, it's really important because GPAC also doesn't add any additional complexity to managing the self-healing, because self-healing is used because we want to deal with complexity, not add additional complexity. UBL, use of self-healing map, SOM, dynamic modeling of the system, really important. Dynamic development of mitigation strategies and detection of errors through differential analysis, and it lessens, of course, the time of detection of the root cause. Okay, what does open source have to do with all this? So we have access to the source code, which is really important because in that way we can extend threat mitigation capabilities. We are able to read the code, we are able to change the code, we are able to mitigate threats which are related to faults in the source code, like a malware which changes some function. We'll see an example later. Facilitating fault root cause analysis, which means that we are able to know the root cause analysis, fault root cause analysis means that we know that we have a threat and where it comes from, which is the source, which is the root. And if the root cause is in the source, we are able to detect it just because we are able to access the code. Really important here, reproducibility of experimental results concerning the machine learning of self-healing. We talk about intelligent self-healing systems. We'll see what we mean by reproducibility of experimental results, and integrate self-healing mechanism into the software. As we said, self-healing is mainly external, but integrating it in into the software also adds some advantages, such as for example, we want to deliver the software with already additional security mechanism in it, which adds additional security to the system. Okay, so what we mean when we say reproducibility of experimental results. Okay, so for machine learning, when we read a paper, we see some numbers, we see results, we see all research that was conducted, but we don't have the code. Paper writes, we use that, and we have these numbers, we have these results, but we don't have the code which was used in order to produce these results. We have all in the numbers, and we can, of course, repeat the process, but it doesn't mean that we did everything correctly. So with reproducibility of experimental results, we have the original test, the test A, with some formulas, numbers, code, source code, and we repeat the test with same formulas, with same source code, with same results, with same number, and that way we can evaluate the test A and just extend the self-healing learning and make it intelligent. Let's see a possible scenario why open source is good for self-healing. Let's say that we have the suspicion that a function was modified. That's why we got an error when we try to run a software. And we have this code, which is the current code, and we do a differential analysis with a backup code which contains the same function but in a healthy state, in a previous known state. Okay, after a differential analysis, we detect that the fault was here. Here we see that it has only the equals sign. And here it has the exclamation mark, which means we don't assign the value, we compare it. Now, how self-healing improves the efficiency of open source software? Two examples with two possible scenarios. When we have this open source software, sometimes we need to modify it in order to use it within the context that it's going to be used, or just so we'll be able to use it with other softwares. But the main thing here is that we modify the software. In that way, it differs from the original software, and the all maintainability is on us. What self-healing does is it doesn't care if what software it is, if it's the original, if it's modified. It only has to do with detection. It detects and it mitigates. And open source software are considered to be more secure because more people are involved, they try it, they evaluate the processes, the functions. But we mostly test open source software regarding the quality of service and not security level. And when we test the security level of open source, it's not comprehensive. Self-healing enhances the security, enhances reliability, and it facilitates the maintenance of open source software. And open source self-healing software, it increases the possibility to utilize semi-supervised or unsupervised self-healing implementation, which means that only partial interaction of human administration is needed or not at all. Human interaction is less required, which is linked to the previous bullet, and it increases the interoperability between self-healing software, which is interoperability is really important, and it's increased because more people are involved. They want to create something that can be used by many, that can interoperate, and that's why open source facilitates the interoperability. Okay, so about the self-healing within the framework of CS-Aware. What is CS-Aware? CS-Aware is a research project, a European research project, and its main objective is to provide a solution for cyber security threat awareness. Yes, it enables the detection, classification, visualization of these threats in real time, and also supports mitigation or prevention. More details you can find on cs-aware, like here, .eu about the project. Okay, so about the self-healing component of the CS-Aware. With regards to the CS-Aware project, an innovative self-healing approach was proposed. It's external to the system, and it utilizes cyber threat intelligence, the knowledge that we use from known information about cyber threats is used in order to know how to deal better with these threats, how to mitigate them, and the best will be prevent these threats. So the learning comes from here and not from other sources, at least for now. The self-healing system is one of the components of the CS-Aware project. It's not the only one, as we can see here. Here are some other components which are associated with the, the self-healing. It's the information sharing component, the visualization component, and the data analysis component. So self-healing is one of them, and it uses cyber threat intelligence, which comes from previous components. The architecture of this self-healing model is, it has main subcomponent and some auxiliary. Main subcomponents are these three: the self-healing policies, decision engine, security rules composer, and auxiliary parser, rule applicator, and logger. And self-healing policies is a static list which was utilized, implemented via a MySQL database, as we can see here in the entity relationship diagram. Okay, the decision engine initiates the composition of the mitigation rule in a generic format, but we don't just stop there. We go a step further and we convert it to a technical format, so it can be applied automatically on some machines, on some nodes, or whatever the admin wants to do. Maybe he wants to implement it himself, but we able to provide technical formatted rules if the vendor of the product provides CLI. We have the parser, which parses the sticks package. We're going to talk about sticks in a few slides. Rule applicator, which enriches the sticks package with the mitigation rule. It writes the rule. And of course, a logger, because a log is always useful. Okay, self-healing accepts input from the data analysis component, which is another component of the CS-Aware. The API accepts only POST requests, and okay, here's the main idea. We got the POST requests via REST API, and it's stored in a MongoDB database. Here is a representation of a sticks package. So what is sticks? Sticks is actually JSON, and it's a language, let's say, it's which is used in order to explain a behavior of threat, in order to note the behavior of the threat and other stuff. Okay, so we have malicious IPv4 addresses, malicious IPv6 addresses, malicious domain, and malicious URL. we mitigate threats that come from all these four, which are noted here. And again, about the sticks, we use sticks 2.0, which is the latest version, because it's in JSON. Previous versions are XML versions. And about the sticks, it describes the threat, and it's really useful for CS aware. We have three alternatives. We apply the rule automatically using SSH. Maybe sometimes user interaction is required. If a permission is granted, okay. If not, then we provide it just as a recommendation, or we provide it as a recommendation from the beginning because no CLI is provided from the vendor, or we don't have enough information from other sources. And we forward the rule to the visualization. Self-healing has root privileges on the remote machine, of course, so we don't face any restrictions. Self-healing user is registered as sudo, again, in order to avoid any restrictions from remote access. And the connection is established only if the LPA, which means local public administrator, has provided such permission. We don't force anything. Okay, here is the activity diagram, which summarizes everything we said about how self-healing works. Self-healing of the CS-aware project. And finally, conclusions. What self-healing offers to open source: enhance system security, facilitate system maintenance, improve service quality. And of course, open source offers to self-healing. It extends and improves self-healing capabilities, facilitate root cause analysis, and extends interoperability. And here is the end. Thank you all. Any questions?
Yeah, we have 8 minutes, so we have time for questions.
I have 8 minutes. It's the first time I'm not out of time.
Yes, we have.
Wow, okay. Any questions? Okay. Thank you again.